Hello everyone. Today we'll be discussing a qualitative comparison of different types of receivers. This table provides a detailed comparison based on various features. Let's break it down together. Receiver types. There are 8 types of receivers we are comparing today. Wideband crystal video, TRF crystal video, IFM, instantaneous frequency measurement, narrowband superhet, superheterodyne, wideband superhet, channelized, microscan, acousto-optic, features and comparison, instantaneous analysis bandwidth. This refers to how wide a range of frequencies the receiver can analyze instantly. Wideband crystal video, IFM, and channelized receivers have the widest bandwidth. TRF crystal video and narrowband superhet receivers have the narrowest bandwidth. Frequency resolution. This is the ability to distinguish between closely spaced frequencies. IFM, narrowband superhet, and microscan receivers are the best at this. Wideband crystal video receivers are the poorest. Sensitivity. Sensitivity is about detecting weak signals. Narrowband superhet receivers are very good. Wideband crystal video receivers are poor without a preamp. Dynamic range. This is the range between the weakest and strongest signals the receiver can handle. IFM and wideband superhet receivers have very good dynamic range. Others have fair to good dynamic range. Speed of acquisition. Speed of acquisition is how quickly the receiver can lock onto a signal. Wideband crystal video, IFM, channelized, and microscan receivers are very fast. TRF crystal video and narrowband superhet are slower. Short pulse width capability. This refers to the ability to handle very short signal pulses. All types are good in this aspect. Retention of signal characteristics. This is the ability to maintain the integrity of the signal. Narrowband superhet and microscan receivers are the best. Wideband crystal video, IFM, and acousto-optic are fair. Applicability to exotic signals. This means suitability for unusual or complex signals. IFM, channelized, and microscan are the best. TRF crystal video is poor. High signal density performance. Performance in environments with many signals. IFM, channelized, depending on bandwidth, and microscan receivers are the best. Wideband crystal video is poor. Simultaneous signal capability. This is the ability to handle multiple signals at once. Channelized, depending on bandwidth, and microscan are the best. Wideband crystal video and narrowband superhet are poor. Processing complexity. Complexity of the signal processing required. Acousto-optic has the simplest processing. Microscan has the most complex processing. Immunity to jamming. Resistance to interference or jamming. Narrowband superhet and microscan are the best. Wideband crystal video and IFM are poor. Power requirements. Amount of power needed to operate. Wideband crystal video and TRF crystal video require the least power. Microscan requires the most power. RF range, gigahertz. Range of radio frequencies the receiver can handle. Wideband superhet has the widest range, 0.5 to 60 gigahertz. TRF crystal video has the narrowest range, 0.15 to 18 gigahertz. Max instantaneous analysis bandwidth. Maximum frequency range that can be analyzed at once. Channelized and wideband superhet, with degradation, have the widest range. TRF crystal video and IFM have the narrowest range. Frequency accuracy. Precision of frequency measurements. Microscan is the most accurate, 10 kHz. Wideband crystal video and TRF crystal video are the least accurate. Summary. Each receiver type has its own strengths and weaknesses depending on the feature. For example, wideband crystal video receivers are excellent for wide bandwidth and fast acquisition, but they fall short in frequency resolution and sensitivity. On the other hand, narrowband superhet receivers excel in sensitivity and frequency resolution, but have narrower bandwidth and slower acquisition speed. The best receiver for a specific application will depend on the most important features required for that application. Conclusion. I hope this breakdown helps you understand the comparison between different receiver types. Each has its unique advantages and potential drawbacks, making them suitable for different scenarios and needs. Thank you for listening.